them on and off again, but that's too much work. So spooky, Garrett. Give a minute or two to the people who are just getting here, get some more beer or pizza. If there is more pizza, I don't know. All right, that's good enough. All right, welcome to DenverScript. Woo! Any first-timers? Welcome. Are you from boot camp? Which teacher told you to come? Come on. Anyone? Anyone? Cole, really? Is it him?
No, no. That's what I'm saying.
Danny?
I'm not.
No. Okay, whatever. Moving on. So, meetups are not possible without sponsors. Co-Talent, which if you don't know is the venue you're in right now. They are a great talent recruiting agency, so if you're in the job market, definitely hit them up. Or if you're looking to hire talent, talk to them about it as well. Because they'll get you cool jobs like Connectify. Hey, I work at Connectify now. They're sponsoring the food. The very gist of it, it's a brokerage ad for industrial machinery. Super specific. Epic Brewing, they give us a discount on the beer, so thanks Epic, even though I'm not drinking the beers. Denver Pizza Company, they also give us a discount on the pizza, so thank you to them. Oh, let's back that up, I need to update this. Code is also sponsoring the beer!
Yeah.
That's the hard one to get. Also, Friend Masters is sponsoring. We will be giving away 3 things tonight, but we won't tell you how or why. But it's coming. So we have 3 3-month passes coming to give out. Cool. What's going on in
Job stuff.
job? That's after.
Oh.
See this slide that says amateur.
All right. So what's going on in JavaScript land? So as always, whenever there's a new Chrome, we always highlight that. So
He means him.
yeah, I mean I will highlight that. If you are new here, these notes will post to the meetup link after, including the highlights video. And so everything we're about to go over in that highlights video, they cover it with code samples as well, which is pretty cool. So some of the stuff that came out with Chrome 66. Black boxing in the network panel is neat. So for those of you that know how black boxing works for scripts you don't care about, you can manually shut them off. But now in the network panel, if you have network traffic that's coming, that you're firing off, if you have some third-party wrapper that you're using to make those calls, previously when you would hover over those, you would just see that third-party library for all of them. Now you can right-click it and say black box that script, and it'll immediately pull away that abstraction and instead shows you your code that's calling the third-party library that's making all those network calls. So that's a really neat use of that is built in. Auto adjust zoom in device mode is one of those just like nice little like sugar things that saves you one more click that's kind of annoying. Yeah, I got one fan in the back who's like knows exactly what I'm talking about. Like, do you guys know like when you're going from like a 6S to another whatever else in like the mobile view in DevTools, how like when you switch from one to the other, it just like takes up the whole screen, you have to go and resize the whole thing. There's now a setting in there where you can click auto resize and it'll never overflow past your screen. So that's a nice little handy thing. HTML rendering in the preview tab. This is actually really cool. When you get HTML response, there's now a preview tab that you can click, and it'll give you a really basic preview of what you got back every time. It's not a full page render, but it is super handy for, especially when you're hitting an API that fires back an HTML response, you can now get a rendered version of what that response is. Oh, pretty printing in preview and response tabs. So for both of those, pretty printing is now available. Yeah, there we go. Fan there too. Cool. I like when people actually are excited about the stuff that I'm excited about. Oh, and then I think it was last month we talked about how they added local overrides. So again, for those of you who weren't here last month or didn't see the update with Chrome 65, so again, when you're playing around with HTML and you make some CSS changes and then you forget to refresh the page and you lose all your CSS changes, right? As of Chrome 65, you can see in there in the release notes how to do it, but you can click a flag, and instead what it'll do is it'll save those changes to a local file on your computer, and then when you refresh, they're all still there. So then afterwards, you can grab that file, drop it into your actual code, and redo that. So, there we go.
I'm actually excited about
that. So that was as of Chrome 65, but in the Chrome 65 video, they highlighted that the only case where this didn't work was when you inlined CSS straight into the HTML. As of Chrome 66, that's now been fixed as well. So any CSS changes that you do, either as CSS attributes or as inline changes, will be there if you use this flag. Like I said, everything that I mentioned here, they show with code snippets in the video, so please check that out if you think that any of that is interesting. So that's what I'm excited about in JavaScript land. What are you guys excited about? Anything at all, as broad or specific as possible? Yes?
Today is React.js's birthday.
Yeah, React.js's birthday!
it. Turned 5, if anyone cares.
Fantastic. All right. So, gentlemen in the back, so as our first contributors, what we always do, first person that contributes and what's going on in JavaScript land, you've just gotten a free 3-month subscription to Front End Masters. So congratulations. Yeah. Again, I would say it's like $30 a month, so that's like a $100 value. So pretty neat. So who else? What do we got? Stuff that you're excited about in JavaScript land? Yeah, now all the hands go up. Yes.
I wanted to learn more about WebAssembly.
Okay.
That's it.
Sweet.
Yeah.
What's up?
NPM audit. So if you don't know, NPM ate another company, which was real sad because it was a good security vulnerability scanning tool. Went away. What they ended up doing was rolling it into NPM. So now when you do an NPMI, you get a bunch of security notices if you're up to date with your NPM version. So.
That was the node security project,
Call
right?
that NPM.
NPMI.
What? Oh, NPMI.
God.
Was that the node security project?
Yeah, I think
Yeah,
Yeah.
it was.
Sweet. Is there anyone in the back?
I'm gonna say what he said.
Oh, okay. Still counts.
Great minds.
Any others? It could be anything, like big news you heard, some cool framework that you worked with, something interesting you heard on a podcast. Yeah.
Do you do paired programming in VS Code?
What was that?
Paired programming in VS Code?
What about it?
Remote?
Oh, really?
Yeah.
Via what? Is it built into VS Code or? Wow. So VS Code now supports remote paired programming. That's awesome. Yeah.
VS Code, as of their current features that we're working on, they finally decided to include horizontal and vertical splitting at the same time for your panes.
Cool. At the same time?
Yeah.
So does that mean you can have like 4?
Yeah, so you could have one vertical and then 2 horizontal.
Oh,
2
wow.
vertical split, 1 horizontal.
Super cool.
Yeah.
I love those like little things. I'm just like, yeah, that's awesome.
I got one.
That could save you a monitor.
Smooshgate. Right? So flat is getting added to the JavaScript language.
Right?
Did nobody hear about
Yes.
Wait, what?
this? Smooshgate?
Smushgate.
Oh, yeah.
Yeah.
I didn't know they were calling Smushgate.
You mean like flat
Yeah,
design?
look into it. It's fun. So
Don't worry,
it's
I'll
just-
go
it's
our
new,
TLDR is for everyone.
yeah, it's like a new applicative over nested arrays, right? So if you got an array of arrays and stuff. I think that's what it is. Sort of like a flat map.
Oh, okay. Oh, so like flattening out like matrices of like arrays of arrays. Oh.
I think there's now flat map.
Yeah.
Like you want to that's fun out there too.
Oh, and are these gonna be built into the ECMAScript?
Yeah, yeah. So,
Standard?
and the reason it's called Smushgate was because the operator was going to be called Smush.
That's
People were like,
cool.
they're like,
Just
there's so many
everybody-
words for this from other languages.
Cool.
I just remember reading everybody bitching about now they have to change their interview questions about flattening the array.
So yet another Lodash helper function makes it to the core language. Yeah, awesome. Any others? Yeah.
Uber released a new database library called
Okay.
which is designed for React applications.
Sweet.
Redux.
So So for those in here, Uber released a new data visualization for React and Redux.
Yep.
Awesome. Cool. Any others? All right. Well, this is a very engaging what's going on in JavaScript land. For those of you regulars, this is one of our better ones. So very good.
What was their VS Code thing?
Which one? There was
Not the pair programming.
There was a horizontal and vertical splitting at the same time. Okay, so here's what we're gonna do. For the other two front-end masters free trials, at the end of the meetup, we'll do for everybody else who submitted, we'll do like a random number drawing, and 2 other people will get that. So we'll take care of that at the end. Sweet. Thanks, guys.
So I see we gotta give incentive for people to start participating. That's good.
We can
Thank you everyone for participating. What were you?
There it is.
Is that what you want? Cool. Who has job announcements? People just raise hands and stand up and announce them.
Only one. Yeah, so my company is Shipify, so we simplify shipping. We are hiring for a full stack engineer at any level. We're based out of Atlanta, but I work here like remote in Southern County, so come chat.
Like shipping or shipping code?
Shipping stuff, shipping boxes, yeah.
Got it. Yeah, but he rose his hand, so he gets to go.
So my company, GigSmart, best way to talk about us is we're Uber for workers. So you use yourself as a skill, and then people find you and offer you jobs. We do basically every job code known to man, everything from development to lawn mowing, doesn't really matter. We're looking for React and React Native devs. We're here in Denver.
So if I want to like do something on the weekend, I could use this.
Yes.
I need to save up for something.
So mid to senior. We will be hiring junior engineers towards the end of the year. We're just trying to kind of staff up heavy first.
Hey folks, my name is Garrett. I'm one of the co-organizers of DenverScript, so I got 2 things for you. One, if this is your first time, we're always soliciting new talks. We've got like a beginner's track, so if you've never given a talk, it's a great place to give a talk, local meetup. It's good to like kind of get you a little more like into things or whatever. So that's that. Talk to one of like either Matt, me, or Guillermo.
I'm gonna correct you on that one. That'd be beginner's track.
What?
We stopped calling it.
Short.
Because we have people, somebody who's been in the industry, you just call them a beginner, dude. That was just rude.
But the point is, to Garrett's point, if you are a beginner and you want to give a talk, the short talk is a perfect venue for you to do it. It's only 10 minutes long, so Matt's just doing a hard time.
Thanks, Matt.
Yeah.
Appreciate it. So there's that. Number 2, I'm looking for a senior front-end developer right now. So I'm working in like the security space at a really cool company. If that sounds like you, please come talk to me afterwards, and I'll tell you more about it. Building some really fun and interesting things. So.
You get to work with hackers. No, literally.
Yeah. Yes, you do.
It's
true.
So I'm with a startup. We need anybody for a small consulting gig that has done HIPAA compliant databases before, preferably not in Java. If you've done it in JavaScript or any sort of scripting language or anything not for a giant enterprise, we'd love to talk to you and pay you a bunch of money. So.
Hey, who likes money? Talk to him.
What's the company called? Dashclean. Although it's still in early stages, but we do have money. So.
It's my favorite. You got a problem? Money. Anyone else? Job announcements? Connected File, I'll probably be hiring a junior to mid-level right next 3 months. So if you're not in the job market now and you're thinking about it, let me know. In 3 months. Cool.
Just keep coming back.
Just keep coming back. Find me on Slacks or something. Cool. Without further ado, Ken. No, I think it's the opposite of dumb. You're using it wrong.
Cool. All right. Welcome everybody. My name's Ken. Thanks for having me here tonight. Tonight we're going to be talking about React Fragments. I just like this gift. This is Syriac. I don't know why. It doesn't actually have anything to do with the talk, but I thought it was kind of fun and fragmenty. I'm Ken. I'm a full stack product engineer. I work at a company in Boulder called Stream, where we build scalable and personalized activity feeds. Basically, any kind of application that has a timeline feed or a news feed runs into a problem called the fan-out eventually, and so that's what we actually solve for them. But mostly I just build dumb fun web stuff, and I like to work on rusty old cars, so if you need an excuse to come up to me afterwards and talk to me, you can always ask me about the cars because I can talk about that for hours. React Fragments, this is sort of the shorter talk. I'm going to keep it on the shorter side. This is mostly just a, hey, these exist kind of talk instead of like an in-depth tips and tricks kind of talk. I'm going to be talking about how to render an array of elements and how to render an array of elements with React Fragment. Why do we even need React Fragments anyway? This sounds dumb. And then an actual real-world example with some CSS Grid stuff. And the, oh yeah, and then of course for slides for this stuff, it's not actually up there right now, but I'll post a link to the meetup group later. A little bit of context here. For the past 6 months that I've been at Stream, I've been working on something called Wins 2.0. If you were on Hacker News last week, we hit #1 and we were on Product Hunt and got all sorts of marketing around that. It was a lot of fun. It's a React Electron app, Redux, all that kind of good stuff. I've been this far away from it for about 6 months, but there are some interesting use cases with React Fragments and with CSS Grid in it. But if you're interested in actually downloading and checking out the app, I totally recommend it. RSS reader, podcast listener, lots of good stuff in there. And I'm sure that you guys have all run into this issue before, where you have your React component right here, class app. I was just using create React app when I was setting this up. And what I'm trying to do right here is I'm just trying to render out a whole bunch of paragraph elements. And you might notice that React generally doesn't like this at all. It gives you this nice little error. Adjacent JSX elements must be wrapped in an enclosing tag. Okay, fair enough. That makes sense. To solve this, you can say, I don't want to do any research and I need to hit my estimate, so I'm just going to go ahead and wrap it in a div. It's what we've been doing since the beginning of, since the invention of the div tag. It's just wrapping stuff in a div, throwing it on the page, maybe throwing a class, some very specific CSS at it. But there is another way to do this, and that's this guy right here. Turns out that you can actually return an array of elements inside of a React component. Notice that there's the commas there. Every single one of these is its own element. This can be a React component. It can be any kind of node that you want to set up there. And Dan Abramoff, the React folks, weren't super happy about this approach. It wasn't like really bad or anything, but they are super focused on the developer experience of React, which means that if you're returning back a JavaScript array when you actually want to be returning back sort of HTML nodes, elements kind of stuff, they weren't too happy about that. So late last year they introduced fragments, and they wrote a nice little blog post talking about it, improved support for fragments, blah, 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 blah. You can see here, down here is that sort of method that I was talking about with the returning back an array of elements. So they knew about this problem before, and there was support for that prior. But late last year, they introduced support for React fragments. And what is a React fragment? Looks a little bit like this. On the left-hand side, left-hand side here, we've got that array method right there, where we actually return back an array. On the right-hand side, it's sort of like we wrapped it in a div, except we're using a specific React component called a React fragment. And this is using React.fragment. You can also just import the actual fragment component directly. And it's going to render out all of the elements inside of this fragment just directly onto the page without any wrapper divs at all. Very nice. There's another way to do this, a little bit more of a concise syntax, where you literally just put some empty tags in here, and somehow it figures it out.
That really works.
It depends on your tooling. It depends on your classes and all that kind kind of good stuff. But this is the planned direction that they want to go with this. However, I noticed that this doesn't work with Create React App, which means that it's probably not very widespread support so far. I do remember the blog post saying a lot about like TypeScript already knows about all this kind of stuff, but unfortunately all of the tooling that I've used so far doesn't have support for this just yet. But it's probably coming at some point. Cool, we've got a way to render arrays to the page. Why do we even need to use this at all? And so I was trying to think of sort of like the abstract reason of why you would use this, and the best that I could come up with was it matters the most when the styling and layout of your elements depends on their ordering and nesting, and like how much of that stuff you got going on. The usual examples that I would give sort of like at the smallest parts is tables, lists, and definition lists, where you have a table data element inside of a table row element, which is inside of a table body element, which is inside of a table element. And you really need to make sure, like, how many extraneous other elements do I have thrown in there? Do I have other divs thrown in there? Am I rendering a table row inside of a table data or a table cell, essentially? That's where it gets a little bit more tricky. But when you should actually use it is when a little bit what we were talking about before. When you're trying to get rid of that extraneous wrapper div, because what you might want to see in your app here is that this is your app right here, and it's got a whole bunch of elements up above there, and then you have your React component, which by default, just you wrap it in a div, and then you have a whole bunch of subcomponents inside of it, then a bunch more elements, and you want to get rid of that wrapper div. That's when you want to use a React fragment. So, the example that I like to give here, and it gets a little bit tricky here, is dealing with CSS Grid. If you've never used CSS Grid before, you'll be able to pick it up. It's not really all that difficult once you start messing around with it. On the left-hand side there, I've got sort of what my grid is going to look like. In this application specifically, I've got my top-level navigation, and I've got sort of like a sub-navigation on the left-hand side. And then on the right-hand side, I've got my content sort of header, and then I have the actual content that I'm going to show on the page. You can see the CSS for this over here. I'm just naming it top nav, header, sub nav, and content. It's literally, that's how it's supposed to look right there. The way that this is supposed to behave is that the items on the left-hand side, all the navigation stuff, is largely unaffected by navigation and state. There's some tabs to it, which is, it's just state stored locally. And then on the right-hand side, all of that content is supposed to change anytime navigation event occurs, or if there's a new state pushed onto the stack. You can kind of think of it like if there is an RSS article on the right, then we're going to be showing the RSS header up at the top and the actual content of the RSS article down underneath. The constraint with this is that our designer said it has to be in this little grid format. You can't just have overflow columns and they sort of move independently. It has to be perfectly laid out like this. And I got to do what the designer says, so I had to figure out some way to make this work, because the issue with this, I guess I should talk about the component structure here. Right now, this is what my sort of React structure is going to look like. I have three siblings. I have the top nav up in the upper left there. I have the sub nav in the lower left, and then I've got the actual content on the right side of the page. But the end goal of this is to have four different elements. We have the top nav, sub nav, content header, and then the actual content. The content header and the content are tied together. Both of those change whenever navigation happens. Which means that if we do the standard div method, and I have my content component right here, this is the content component which encapsulates both the top and the bottom of that right-hand side of the page there. If I go ahead and wrap that in a div, what's going to happen is that when it renders out, it's going to look like this. It's going to have that extra div in there, and this is going to totally break your grid. CSS Grid will not know how to actually render this because it thinks that there's only 3 elements inside of the grid. So that was an issue. The nice thing is, to fix it, we can just use a React fragment. Sorry about the overflow here. So we've still got the exact same component structure here. But instead of wrapping everything in a div, I just go ahead and wrap it in a React fragment. Now remember that no div gets rendered. There's no nesting of that div when I use a React fragment, which means that this header and this content, they're going to be siblings. They're going to be sibling elements, and they're going to show up alongside as siblings as the top nav, sub nav, and you have the header and the content. So that's when you would need to use a React fragment. It's a very, very unique, like weird little edge case, but like this is like stuff that, you know, if you do enough research, you'll find out that these things exist, and it's going to make your life a lot easier in certain situations. Quick recap, React Fragments basically does not render any sort of wrapping div. You would use it to get rid of these wrapping divs. It's got that other weird little syntax, which is coming out eventually. But it's mostly used just to render an array of elements easily. That was sort of the weird little cognitive leap that I made. It's like, it's not necessarily just for removing divs, it's for rendering an array of elements. And a bunch more of this information is in those release notes, so feel free to just check that out. It's got a whole bunch of information around that. That's what I got. Thank you guys. And I assume I got time for questions.
Yes.
Short time.
Yeah.
So when you have that the concise syntax of just like the empty hanging tags.
Yeah.
If you're in a framework or whatever, or you're using like a tool that supports it, do you need to import fragment anyway and then it recognizes that, or is like that just recognized out of the box? I mean, it's still.
I haven't experimented with
Okay.
it because I don't really
Yeah.
want it to work. What's up?
You do have to import it.
You do have to import it? Yeah.
So you import fragment and then it just translates that for you. Okay. Cool.
I got you. Yeah. So you have to. Yeah.
So you could use this to render out like a media card with a picture and a description of some sort. If you don't know how long the list is going to be, you can use the React fragment to render out and whatever the nutrients in the database in this specific format without adding the divs that are going to mess with the layout on the page.
Yeah. I mean, like, I would say that for a media card, you would probably have some type of wrapper element for the media card. Just say, like, yes, here's div class name media card, so just like you can actually attach that and style that independently. And inside of that, that would have a whole bunch of arrays of things. So I think in that case, it's still totally applicable to have a wrapper element for that, or some kind of wrapper div. But if you were talking about like looping through.
So imagine you're getting a
Oh, I see.
playlist for music and you want the album cover and the album description, or the album cover and all the songs, and you have them laid out in the card. And the card would be like all four paragraphs.
Yeah.
That has its own layout. If you add a div to it, it's going to be separate page.
Yeah. You could totally use React Fragments to lay out something like that. I will say that but even so with that stuff, you're probably gonna have like a media card container or something like that. And so it's like, yeah, totally. If you guys want to use React Fragments, go for it. I really like this sometimes. It means that you don't have all the extra divs in there. It's awesome, but like it's not like totally necessary for you to get this stuff done. It's just this one weird niche little problem. Yeah.
So the last question was you have to import React fragment.
Yeah. It sounds like you do have to import. You don't?
You just, if you have React import it, you can just do React.capital fragment.
Okay.
Yeah, but if you want to write that out, you just do an import React, comma, and then destructure out fragment.
Right. Yeah. No. So my question was like, to use this syntax, you have to import the fragment first. Right?
I don't know. That's just, so that's in the official documentation. It's just a short syntax for fragment, and fragment is imported when you import React. I can actually try it.
So that's only for the shorthand, right? No? So if you just have import React from React, you can just do fragment.
React.
Well, right.
Right, that's what we're talking about. There's
Right.
two ways to import it. You can do that, but if shorthand is just to do the comma, destructure out fragment, so you can just do a fragment tag.
Right.
So you don't have to do that, it's just that if you want to do shorthand.
Right.
It's like this guy. I'm not typing in React.component because I'm restructuring out component whenever I make that import statement. So this is probably not the best way that I could have explained it. It's just like, yeah, copy and paste some stuff.
Hey, made for a good conversation.
Good enough, right? Any other questions? Yeah.
I'd just be morbidly curious if you know what's going on underneath the hood here. Like, so are they going, oh, I'm not going to throw that dump in there, and continuing, or is React actually doing something interesting with filing the HTML in a way that doesn't touch your HTML, but somehow?
I think it's literally one of the dumbest components. I was looking at the source code the other day for this, and I think it literally just returns the array.
It does.
Yeah, that's all it does. Because you can return an array from a component it renders, so all it does is take the children and just returns children, which is already an array. It's just syntactic sugar. Nothing really special.
While he's right, it's the dumbest thing. At the same time, I love it.
I do it all the time.
Yes.
I definitely think if you're, definitely like the other question was if you're dynamically bringing things in from a server and you're like, it needs to actually do this stuff as opposed to just plopping my HTML, that sounds like pretty useful.
It's actually smarter than that. And the documentations, if you were to put React.fragment with regards to being important, and then just put TD as in table data, it'll actually put in a table and then a table row with your table data. So it could be very dependent on what you're actually wrapping with React Fragment, but according to the documentation, it's smart.
That actually scares the shit.
Yeah.
That's like when you forget to close a div in Chrome and Firefox. You're like, everything's fine, but then you get Internet Explorer goes.
Yeah.
Awesome. Any other questions? Sweet. Thank you so much.
Next up is Sienna. Sienna, right?
Sienna, you got it. Yeah. Nailed it.
Didn't even have to go to pronunciation.com.
You guys want to get refills? There's plenty of beer still.
Yeah,
once
take
you're
a
getting
second.
set. Take a minute.
You have a good laptop.
I think I stuff too bad.
Yep, you're good.
Yeah.
No, you have the correct laptop. Should have said yes, I'll take the older laptop and say the new one.
No, dude, oh, really? No, not at all. That's not so hard to look at. Yeah? Yeah, man. It's so I told you about something
I would really love
All right, guys, let's grab a seat, and we'll get started back up here.
All right. Hey, everybody. Can you hear me? Should I get closer to the mic? Good?
Yes.
Good. Okay.
No, louder.
Closer? Louder. Got it. How's that?
Perfect.
All right. So I'm Sienna Wood. I'm here to talk about a recent project of mine, which is a peer-to-peer snake game. So, whoops, back. Got a little video here. Hopefully it'll load as it happens. So this is players joining the game, indicating they're ready. And here's the game. If you are unfamiliar with Snake, now's your chance to learn about this general game. So basically the object is just to not run into the other snakes. Generally speaking, there's also walls that you're trying not to run into, but our game board wraps, so you can't even run into the walls. So you just have to not run into the other players and not run into yourself, right? If you cross your own body, you instantly die as well. So that's Snake. I'm done. Thank you. Okay, so yeah, so that's the basic game, just so we're all on the same page there. All right. And so what makes this interesting, what we built is it's actually a peer-to-peer Snake game, direct peer-to-peer connections, no central server. So what I'm going to talk about is the advantages and disadvantages of building that kind of thing, right? The different multiplayer gaming architectures that there are, network architectures. And then the primary problems and our solutions that we came up against when we were trying to do this. And then some optimizations that we made to make it more efficient, and then future work we have in mind. Okay, so all distributed multiplayer games have these things in common, right? You have users in different places, you're playing against each other, so the game state is replicated for everybody, and then when you do an action, it's optimistically updated locally and then broadcast to everybody else, okay? So the traditional model for this type of game is client-server, right? So you have a dedicated server with lots of power, with a good network, and everybody communicates with that, and it has your, it's the authority on the game state, right? So if you have any kind of conflict, you go server, what is it? And they go, this is what it is, right? That's it. So powerful, you got the game authority. Drawbacks, it's expensive. It's a little bit pale in that corner, you can't probably see it, but yeah, central servers, they're expensive, they're powerful, and therefore expensive. And also, if you only have one, players that are really far away are going to have a whole lot of latency. So you generally want to have many. So it's even more expensive than you thought, right? And it also gives you a single point of failure. Now again, if you have multiple, then you have multiple single points of failure. So only marginally better. Okay, so another model that had been tried here is basically taking a client, eliminating the central server, and making one of the clients a central server. So this is the worst of all possible worlds because you lose the power, right? The only advantage in this is that it's cheaper, right? Because you're not buying those big, powerful servers, right? You're just using client resources. But then if they're underpowered, the performance suffers for everybody. So it's pretty lousy. But a true peer-to-peer configuration does have advantages. So it is cheaper, so that's cool. But you also have no single point of failure, right? Because everybody's connected in different ways. So you can lose one node and you're still in business. Also, if you are in proximity to the other players, this is your lowest possible latency because you're just talking straight to each other, there's no intermediary, at least in some network topologies, right? So it has the potential for the lowest possible latency. But the real big disadvantage is that there's no central authority on the game state. So that's the biggest challenge we came across. So why did we do this at all? So if we were aiming for like best game performance, right? We were like, we want everybody to have the best Snake game experience they've ever had, right? We would go with the central server, right? Because we've got that tried and true model, we've got the authority on game state, we've got that powerful machine that we can rely on. But we see a lot of potential in the sort of peer-to-peer things, distributed things, the decentralized things, and so we were like, cool, let's see what we can do here. Let's just experiment. We'll choose a simple game, but we'll choose a fast game, not a turn-based game where all the latency issues are covered up by waiting for somebody to take a turn, or with casting time, right? We have the infinite cast going on over here, right? I mean, we could have picked a game that would really cover up the challenges, but we deliberately were like, let's expose them, and let's face them, and let's see what we can do. So, yeah. So the primary challenges were synchronization, providing a good experience for users even when they haven't gotten the peer data that they're looking for, right? When there's been some sort of delay, there's too much latency, we haven't quite got things that we need. How do we keep the game looking smooth, acting smooth as best we can in the absence of real data? And then how do we replicate that game state without a central server? So I'm going to talk about synchronization first. So if we don't have, we'll never have real synchronization, right? Because we're always going to have latency. There's going to be small delays. But if we don't have an approximation of it, then we're not really playing a multiplayer game at all, right? You're not really playing against another person in real time, you know? So we have to get there. We have to get close. So what we implemented was sequence numbers, and we called them time units or TUs. And the way that works is there's a local timer, and it increments at a regular interval. In this case, it's 250 milliseconds. And then the peer-to-peer messages and the local data structures use these, right? So when I send you a message, I flag my coordinates for which TU they apply to. And then you know how to integrate that into your structure because you've got the TUs flagged. You're psyched, I love it. So when you think about the snake game, the body of the snake is actually the history of where the head has been, right? So we've got, in TU16, the head of the snake was at, coordinates row 3, column 3. And then TU17, 1 square away, 18, 19, 20. So the way to get the snake body is to merge these together. So there we have 16, 17, 18, 19, 20, and now we have a snake body, right? So it's really, these TUs are really important for just building the board, building the plane board. So, does that make sense? Yeah, sweet. Okay, so we also use the TUs to check for collisions. So we defined a collision as it's when your head, your snake head, is occupying the same square as any of the other snakes or any other part of your own body, right? So basically what we do is we take the positions of the peer snakes and we take our own snake, and here the head is colored red just to illustrate this point. So then we separate out the head, we combine these pieces, which is the other snakes and then the rest of our body. And then we go, okay, do we have an overlap? And in this case, indeed we do, right? So we have to, it's kind of interesting because to get the whole board state for TU35, we have to be looking back in the history for all the snakes to get the whole snake body, and so we check against that. So here's some code. I won't go through it because whenever I've been going through this talk, it's been going over time, so we'll just move on. So we also use the TUs for latency tolerance. So if someone is just too latent, that it just becomes, the game becomes unplayable. There's too much delay, you're not really playing together. Then they need to be kicked out. So basically, we compare the most recent message from all the peers with our own local timer. And if there's too much discrepancy, then we mark that snake as dead, kick them out of the game. And they just have to wait and play with somebody who's closer to them or something. So yeah, so if we're at TU140 and we're getting messages from the peers, they're at TU138, that's fine, we can deal with that. 2 TUs, not a big gap, but cool. But if we're at 150 and they're sending us 138, that's not gonna work, right? You can't be 12 TUs behind, you can't be 12 squares behind. It's not a multiplayer experience, so that player would be kicked out. Okay, so what do we do when peer data is missing? What do we do when we're waiting around for peer data? It's still within the tolerance, but it's not here yet. We could just freeze their snake, but then it's not a smooth playing experience. So yeah, that would be the lockstep model, right? And then essentially what happens is the snake game becomes a turn-based game because you're waiting for everybody to submit their moves, right? So you would wait, and then the game would move as slow as the slowest peer, which sounds super fun. And the speed would also be irregular, right? Because it would just depend. Oh, the latency's more, and then it was less. So we decided that this is not a viable solution at all. So what we did was we implemented dead reckoning, and that's a two-step process. So you predict where your peers are going to be based on the latest information that you have. And then you need a convergence algorithm to converge your guess, right, your prediction, with the actual data when it arrives. So the prediction is really easy here because it's a snake game. The snake goes forward unless you tell it to do something else, right? So we just go, okay, where were they last time we heard from them? They were in this row, this column, and which direction were they going? And then we just start predicting. Well, if they keep going that direction, they'll be here, then they'll be here, then they'll be here. But then when we get real data, we will replace those predictions with the real data. So, and then when it comes to convergence, basically we made this really easy on ourselves by always keeping our predictions separate from our canonical peer data. So we basically had a snake data structure where we would keep the information about our own snake and all the snake data that we're receiving from the peers. And then we would aggregate that into the boards for the display and also boards for collision checking. And then on top of that, we would add the predictions. So when every time a TU takes over and we need a new board, we discard that board with the predictions. We populate it with the new peer data that we received, the most recent peer data we have. And then if we still need a few predictions, we add those on top. And that might sound pretty inefficient, but we managed to do some optimizations that helps us get through this pretty cleanly. So basically, this is how it works. If the light squares are the predictions, we've got those, and then we get new data, and we adjust. And then we've still got a prediction on the green guy, and then we get real data, and then we've got a prediction on the blue guy. So that's how that goes. So then we had to figure out, when we're checking for collisions, are we checking against the predictions or only against real data? Now this was an interesting question because if you don't check against the predictions, you're gonna see collisions and you're not gonna die. So it's pretty counterintuitive. But at the same time, if we include the predictions, we're gonna have a different experience for different players, right? Because someone might be at a different place in their receipt of peer data than you are. So you might see a collision when they didn't see a collision. So if we were going to be consistent, we would have to only check against the real data. So ultimately, that's what we picked because we wanted the shared game experience. We wanted consistency as much as possible. So essentially, what happens in practice is that you'll see a collision and then it will correct itself, right? And so you'll go, oh, okay, so that wasn't a real collision. Because you'll get that peer data and it'll correct and you'll understand what happened. So you'll have a moment of like, shouldn't I be dead right now? But it'll correct and you'll be able to tell visually what's going on. So yeah, we did just the real data. Okay, so now the consistency of the game state. This was probably the biggest challenge. What do we do? How do we ensure that everybody's playing the same game, looking at the same board? How do we make that happen? So the first question we had to answer is who's the authority on the game state, right? So if it's not a central server, we could have made it one of the peers. Well, then you're pretty much doing that client as host architecture that we talked about before that has no advantages. Just kidding. Very few advantages. And so we were like, we don't like that. And the thing is, you'd have to pause every time if that particular client goes away. You'd have to pause the game and redistribute the state and then start again, right? And we wanted to really avoid those sort of delays and disruptions. So we didn't like that option. So another option would be each peer is responsible for a certain region of the board. But then we have to have a whole algorithm about who are you telling where you are, who are you asking where, for certain information, who is checking for the collisions, and so it became really complicated. We were like, that's not promising. So what we decided to do was pretty intuitive, which is just that each peer is in charge of their own snake. They're the authority on their own snake. So you always know where your snake is. No one's going to tell you otherwise. And you check for your own collisions. And if you leave in the middle of the game, your snake just dies and everybody plays on without you and it's no problem, no disruption. So that's what we ended up going with. So basically, you are broadcasting out to the peers your own snake data, and they are broadcasting into you their own snake data. Pretty simple. So then we had to figure out our transport protocol. So the WebRTC data channel, which is how we establish these connections, which I didn't even mention yet, I realized. So WebRTC is usually used for like streaming video and audio, like for video conferencing. And there is a data channel in there that is normally used for stuff like a chat box, right? But it has a lot of, it's configurable, as you see from this slide, and it has a lot of, potential there. So that's one of the things we want to do with this project too, is sort of explore the possibilities with the WebRTC data channel. Anyway, so it can be configured to be a reliable messaging system or unreliable. So in the reliable case would be like TCP, so you'd have in-order delivery, you'd have no duplicates, but where the problem really is that it compounds the delays because of latency, because you're going back and forth, you're implementing that, that reliable messaging with acknowledgements and counter-acknowledgements. So basically to get one message, you have to have 3 messages, at least. And then if you have an error, you can try again and have more messages. So it really compounds those latency delays, and latencies are bottlenecks, so we didn't want to do that. So we went with the unreliable messaging, which is fast, but then it introduced new challenges because messages can be lost, they can be duplicated, or they can be received out of order. So to know where the snake is going to be next, any snake, you need to know where they were and then which direction they're going, right? So just a directional command, that's all that's needed. So this begs the question, can we just send those directional commands peer-to-peer? Can that be our whole messaging protocol? The problem is that if your snake is there and your commands are right up, right down, these are the possible scenarios that can happen with your peers if messages are lost or received out of order. So you can see very quickly we get serious distortion of the game state, and everything falls apart. You're not playing against people anymore. You're playing against randomness. So we realized that was not going to work. So what we know right now is that the authority is that each person is the authority on their own snake. We've got that sorted. But our problems that we have to deal with are lost messages, out of order messages, duplicated messages, and state distortion. Okay? So here were some solutions we thought of. Slow everything down. That's not unfun, right? That kind of ruins the nature of the game. So we were like, we don't do that. We could use redundant or overlapping messages. Okay, that's viable. We could use a buffer to reorder the messages, remove any duplicates before those actions are actually applied. But that, again, sounded like more delays, more computation. We wanted to avoid that if we could. Another option, send more information in the messages. Instead of just the directional commands, we can send coordinates. They're more stable, though they're less sensitive to changes in order, things like that. And then we could also use an eventually consistent structure, data structure, that wouldn't be distorted by these problems, right? By this unreliable messaging, these challenges. So basically that's how do we prevent problems instead of resolving them later, right? So those 3, yeah. So we decided to not do those 2 and pursue these other 3. So the first question became, when are we broadcasting data? Our first thought was you only need to broadcast when you make a change, when you change directions. Otherwise you're just going in a straight line, right? That sounds like the most efficient way. But then we were like, okay, wait, we're doing unreliable. What if that message is just dropped, right? They'll never know that you made that movement. And then again, we get this state distortion. So, and the other thing is that you have no data from somebody who's traveling in a straight line. And then if you don't have data from them, you're predicting where they're going to be. And you're predicting correctly, but you don't know that. So you can't check for collisions against them because you're not sure that they're there. So, so that didn't work. So another option is to do regular intervals, regardless of what commands are issued and when. This is better, but the gap has to be small so that we get enough redundancy to prevent data from being lost entirely, right? We want to be able to, like, if we lose one message, that's okay because we've got enough redundancy that everyone will still get all the data. So what we ended up doing was we sent with every TU tick. So every time you commit a new move with your local snake, your local snake, right? They move forward 1 square, you send that out to everybody. So this worked really great because the constant stream of updates meant that everybody had the most recent. I can step this way. So so everybody had the most recent data possible, right? It was getting out there, it was getting broadcasted as soon as possible. And the great thing about this too is that we didn't have a performance penalty because our bottleneck was the latency, not the computation. So when we implemented this, we saw no performance change. It was working better. All right. So here's how we did the redundancy in the peer messages. So instead of just sending one coordinate pair with every TU tick, we sent 5. So, at TU 138, we send our coordinates from TU 138, but also 137, 136, 135, 134. So this worked great because if we dropped this message, then we would have that information not just in the very next message, but also in the 3 following that. So we had really robust redundancy. Okay, so here's our progress now. So we've got, Z40, we've dealt with lost messages, and we've started to deal with the out-of-order messages by doing the TUs, right? So we still have to deal with duplicated messages and with the state distortion broadly. Okay, so this was our most important step here, was we implemented a CRDT, a conflict-free replicated data type. This is the same data type that's used in eventually consistent databases like Redis and React. And what it is that you constrain the way the peer data is merged into your local state, and then you mathematically guaranteed that you will arrive at the same result with the same data. So there are 2 types of CRDTs. There's operation-based, but operation-based is not tolerant to duplication. We knew we had to be tolerant to duplication. So we knew we needed a state-based CRDT. So in this model, you transmit pieces of the local state. So it's actually a Delta CRDT that we did, because we did portions of the local state with that extra redundancy thrown in. So it's the change, but with some redundancy thrown in. So yeah, it's a little bit of a variation, but yeah, and this tolerates both the change in order and the duplication. So this is how it works. So the players broadcast their local state, which is those the coordinate pairs keyed by TU, and then we merge those messages into the local data structure with operations that are commutative, associative, and idempotent, or idempotent. Idempotent, I like that better. So the order needs to not matter, the grouping needs to not matter, and we need to be able to do the same thing 5 times, and it doesn't matter, like multiplying by 1 or adding 0. It needs to not change the result as compared to if you just did it once, right? So in terms of our scenario with these snake bodies, this is how it works. So if you're getting these fragments of state, and they come in that order, the top order, you arrive at that state. In the bottom, if they come in the bottom order, you arrive at the same state, right? This is what we're going for. So associativity, doesn't matter how they're grouped, right? So if we get these 2 pieces and merge them, and then we take that merged piece and we add a new piece, again, we arrive at the same structure. And also if we have duplicates, we arrive at the same structure. This is what we're going for. So the way we implemented this was in a G set, or a grow-only set. So basically, this is a JavaScript object, and adding new key value pairs to an object is commutative. Adding new key value pairs is associative, and adding new key value pairs or overwriting them with exact copies is idempotent. Ta-da! Right? So the trick about our CRDT is that it's not a mathematically pure CRDT, because we're purging old data. We just wanted our space complexity to not get out of control. So we did purge old data, and so each player is going to purge old data as they hit the limits, and that introduces slight variations. But it's only in data that's no longer relevant to the gameplay. We're not using it to make boards. We're not using it for collision checking. So we're safe in terms of everybody's game board and collisions being the same. So we've solved these issues now. We've got authority. We've dealt with lost messages. We've dealt with out-of-order messages and duplicated messages and the state distortion. The CRDT filled in the rest for us. So, and now I want to talk about a few optimizations that we did, because we wanted to make sure that, so we knew latency was going to be our delay. We wanted to make sure that was the only delay. We wanted to be as quick as possible, as efficient as possible. So we started by optimizing the snake body structures. So we needed fast insertion at the head, fast deletion at the tail. Sounds like a queue, right? But we also needed fast lookup by TU, right? So our initial implementation wasn't indeed a queue, but we got that O then for the lookup, and that was ugly. We were like, we could do better. So what we wanted was a linked hash map, but this is JavaScript, not Java. So we were like, So this would get us the O1 for all three, and we found a solution because this, linked hash map's not natively supported in JavaScript, so we found a workaround. So this is our pseudo linked hash map. So basically, we got the positions part of the object over there on the left. We have a newest, we have an oldest, and we have the by key. So the part with the coordinates, where the keys are TUs, is in the by key part. And then we have essentially a pointer to the oldest and to the newest. Because they're integers, we can just increment them as we're moving forward in time to get the next one in the sequence. So those become our pointers. So with this, this is our simple code for adding and removing, and then the lookup. We got O1. We were psyched. Okay, the game board itself, we also optimized. So initially, we did a sparse matrix. So we were using undefines to push data over into the correct coordinates. And this was okay because it was intuitive in terms of the way you look things up by row coordinate, kind of like that. But it had excessive space complexity. So we were like, we can do better. There was also a slow merge, which I'll explain why we need a merge later. So we improved it by making it a two-dimensional hash, right? Instead of an array, we're doing a hash. So then there was better space efficiency, we had the same coordinate lookup, but we still had that, we had to do a deep merge. So we made it a one-dimensional hash, we flattened it out, and then instead of doing coordinates, we did just numbers, right? Each square has its own number, and then we got our efficient shallow merge. So we also did this optimization called headsets, and this takes a minute to explain. It's a bit awkward. So basically, if you need to aggregate snake data together to make boards and to do collision checking, if you can pre-aggregate some snake data from your peers, then you can reuse those over and over again, right? Because for TU 150, we're going to use that board, right? Those head positions of those snakes at TU 150 for TU 150, and then for 151 and 152, because we've got the length of the snake, right? We're looking back in history to see where the head was, so we're going to reuse those again. So what this does is it aggregates the heads of the snakes and keys them by TU. So then we can reuse those, and we've already sort of done a part of the aggregation, so these become reusable. Does that make sense? Okay, so this might help, right? So if this, at TU16, this is where all the snake heads are. We've got that. TU17, that's where all the snake heads are, TU18, and so on. We merge them together to make the board for TU20. And then we're not going to need 16 anymore when we go on to the next TU. But we still will need 17, 18, 19, and 20. So these get reused for the next board. Does that make more sense? Yeah, I'm seeing some nods. Sweet. So going back to here, we also did this same sort of pseudo-linked hash map where we've got pointer to the oldest and the newest, and then we've got our headsets by key. Yeah, got a little fancy animation for you. There you go. Okay, so I'm going to skip this again because we're running out of time. Another optimization we did was we had to pick a peer-to-peer network topology. And what we ended up doing was we wanted to just minimize latency. So we did a full mesh where everybody's connected to everybody else. And this was great for a sort of medium, small amount of people, right? We've got it capped at 15 right now. Works fine for 15. It wouldn't scale up though. You have to come up with something else. Ideas for future work. So we'd love to do automated tests on the peer-to-peer connection, but I mean, that's going to take a lot of structure. It's going to take a lot of work to set up and monitor pseudo peer-to-peer connections. So that's an area we'd like to explore. I have no clue how we make that happen, but we're very interested to know. We would also like to test the latency between the peers in a particular group. So then maybe we could adjust the game settings slightly to make the gameplay ideal for this particular group, right? Slow the speed a little bit, right? Try to optimize. We'd also like to migrate to a more up-to-date library for the WebRTC piece. We were using Peer.js, which provides the code for the signaling server, which we really liked, but it's way out of date. And I'm hoping, so WebRTC just this year, 2018, we got support in Edge and in Safari. So I'm hoping there's going to be a little bit of a renaissance here, and maybe we'll see some new things come out. So that's exciting. And then we were thinking about scaling a little bit too. So if we increase the number of players, computation would become a bottleneck pretty quick. And we thought to address that, we could maybe share larger chunks of the state so that individuals wouldn't have to compute as much locally. Also, again, like I said, the full mesh topology would not work. We'd have to come up with a different topology and messaging protocol to go with it. And then another thing we thought was if we made the game board a piece of a larger world, right, kind of like Slither.io or something like that, then we'd have to implement an interest algorithm. So everybody's only computing the state that they need for their sort of region. They don't need the whole global state, just what they're interested in. So, yeah. So thanks everybody. Again, I'm Sienna Wood. This is how you get a hold of me. This is what I can do, and I'm looking for a job. Thank you everybody.
Another question, you clearly put a lot of thought into all of these different phases. And so I don't know a lot about eventually consistent databases, right? But in the bit that I have heard, right, one of the immediate things that they say is that you probably don't want to use it for things that are really important with like real time, right?
Yeah.
Because the whole idea is they're eventually consistent, but like not. So as you thought through that, like, with that being sort of like the knee-jerk thought, is it because 250 milliseconds isn't that real time, so it's okay, or is it because of your peer tolerance when you kick people out, or is it because of your history, or is it all that combined? Like, what kind of like kept you from like being like, oh wait, they say don't use it for that, and so, you know what I mean? Like,
well, yeah, absolutely. And again, if we were going for like the best user experience, right, we would have gone for Essential Server, right? This project was genuinely meant to be experimental, right? We were like, let's just explore this space, see what we can do, see if we can push the limits, what we can solve, and what's going to always be a problem. So yeah, we were stretching against the constraints on purpose. Yeah.
that's super cool.
Thank you. Yeah.
So in the deltas for when you would kick a latent snake out of game, was it a constant or was it linked to the length of the snake?
Yeah, that's a good question, and I don't think we've honed it. Right now we have it set at a constant, and we have funny behavior sometimes where I think there'll be like a little like hiccup in the network, and then 5 people will die at once, and then it usually ends the game. So then it'll say this person wanted, this person wanted, this person wanted, this person, you know. So yeah, so there's some bugs to work out there, but yeah, I mean that's a good line of thinking. Like maybe it can be a little flexible and be responding to I don't know, network conditions or something somehow.
Like
Yeah.
the length of the snake plus 1.
Yeah.
Awesome talk. Terrifying to have you on the job market. I have a couple of more technical questions, but the broader question is someone who's interested in convincing people WebRTC can actually do something cool for them if they don't code. What direction do you see the protocols heading? Because I noticed there's a lot of TCP-like, UDP-like, and it's still just the Wild West like the early web, or is there a lean toward this is our real challenges that we use already?
Well, you know, I'm hoping, because I mean, we just got the broad compatibility, right? And I have a feeling that there's going to be a lot of homing and a lot of clearing things up in the next couple of years. As far as a specific direction, I don't know. I mean, maybe you have some thoughts on that, but but yeah, I'm really excited to see.
Well,
Yeah.
it sounds like it could be multiple protocols based on the need, like a real-time game versus a long data stream or something like that. But I feel like that was probably said about the early web, and that didn't melt it.
Yeah. It seems like the WebRTC, it kind of is like blockchain's ugly stepsister or something, right? It's like this sort of like no man's land, oh, WebRTC, right? So I'm hoping people will start to see its potential and be interested, move it along. Yeah. Behind. Yeah, sorry.
So one of the things about that, where each person is responsible for their own state, essentially, is that can lead to cheating. A lot of games like this.
Yeah, we totally thought about that.
So, do you do anything to address that? Is there any
So we thought about it and we decided not to, because we were like, we want to spend our engineering time on this, right? And so we decided to just go, well, it's a low stakes game. Right? I mean, there's no way, right? So we kind of thought the incentives for cheating are so low, we're not going to spend our engineering time working on it. But absolutely with anything higher stakes than this, we would have.
Well, I guess the question question was like, do you have any just like initial thoughts about what you would have done to address that?
I mean, the first one is literally just obscurity, right? You just uglify your code and things like that, right? That would be a good step. Yeah, I mean, I suppose you could do, I mean, as we were looking into this, we sort of came across a variety of different solutions, and all of them seemed too intensive for this project. So yeah. But there are solutions out there. That's the good news. Yeah.
Well, I just wanted to kind of comment. One idea you could do is you could do 8 public keys, and every client gets their own private key, and then everybody changes the public key, and then you can do signatures like that. But
That's true. Yeah.
I don't know if that was, but yeah, I mean, I just want to add to that.
Yeah. Anybody else have any other ideas about security? No. Yeah.
I had a really cynical dev I was talking to about this talk back where I work, and he was talking about how you manipulate your latency to delay your packets.
Yeah.
It sounds like machines are getting good enough to tell me clients, hey, your latency is not that bad, we think you, and now you're giving us these latent packets. And to protect a reflection now or something.
Yeah, if you get on YouTube, you can find things where people literally wire up a switch to their network, so they'll switch it off for a few seconds and then switch it back on again to cheat. It's wild. Yeah. We didn't think we'd be facing into those kind of hackers, but but yeah, it's out there for sure. Yeah.
Another question about clocks. So on the TU, how do you generate? I mean, are the TUs in sync, and if so, how do you deal with that?
So they're not. I mean, in terms of real life in sync, they're not, right? But in terms of the signal to start the game is sent out at one time, and as soon as everybody gets it, their timers start, right?
So
there's gonna be a slight phase shift.
Sure. So how do you deal with hangups in like V8, for example, on the VM? If there's a delay for whatever reason, it's going to cause the TU shift to be an extra. There's just something that's not firing on the event machine or something like that.
Yeah. So if it's still within the tolerance, then we're okay. We'll just do our predictions to try to keep things smooth, and that snake will always just be correcting a little bit all the time. So it's not perfect. It's not ideal. Again, a central server would solve that, right? But yeah, as long as it's within the tolerance, we can sort of go, it's still playable within this range, so we'll leave it. We'll let them stay.
I think I might have missed it, but how do you do client discovery?
Yeah, so there's a tiny node.js server, and we have, like I said, pure.js provided the server side, matchmaking stuff. So I do actually have a slide that shows this. So this is the way it works with WebRTC establishing the peer-to-peer connections. So first you get a web socket to the signaling server, between the client and signaling server. And the signaling server says, touch a stun server. It'll give you your public IP address, and it'll tell me if there's any limitations on your ability to connect with another peer, like NAT symmetry, right? So then you give that information back to the signaling server, and then it goes, cool, now I know your info, and I know this guy's info. You guys can either connect direct peer-to-peer, or we'll put you through a relay server, a turn server, to get around that problem of having like a symmetrical NAT issue, right? So that's how that works. Yeah.
So since you just mentioned NAT, did you have to configure doing anything like port forwarding for something special for these clients?
There wasn't anything. No, it was really nice. I mean, basically, when we do web conferencing, we're connecting this way. So if your computer can connect via web conferencing, you can do this.
Oh, I see.
Yeah.
That's not a good argument.
That's what the turn server is for, typically.
Yeah, the turn server. Yeah. If there's weird stuff going on, you get to go through the relay, and that helps. Yeah.
So I think you mentioned this before, right? But so then when you're doing a TU count and you're looking at latency and like when you drift too far, you kick off. Who's responsible for the kickoff? Is it like you just like kill yourself? Is that the idea? Because you're responsible for your own state, or like since there's no central server, like who's doing that checking for like when you're behind? Like how would you know? Since it's late,
So exactly. So basically, everybody's network tends to be that you're slow to upload and fast to download.
Sure. Yeah.
So we were like, okay, so we don't love making someone else responsible for you because it was kind of violating our idea of you're responsible for your own snake. But you're not going to know if you're latent.
Right.
So someone has to tell you. So basically, you are monitoring the other snakes and comparing them to your local state.
Okay.
And you're saying, oh, you sent me this to you. Wow, you're really behind. You're dead.
So obviously it's just like a low stakes game and it's like happy path, like just playing with technology. But it's the idea then that like is it have to be a consensus on like a certain amount of people see that you're behind, or is it can one person send a kill signal?
Yeah, so we thought about this and we wanted to implement a consensus system. Like, I vote that this guy's dead, and if you get 2 votes, then they either die. But what we have right now is just the instant kill, right?
Sure.
You just go, that guy's too late, he's dead.
Cool.
So, yeah.
I think the way to choose voting the best player off the other.
Yeah. There you go. Another way to cheat. That's what we've introduced. Dang it.
Everyone's like, how do I cheat? So they'd be like, this is so great, or is it, well, here's how I would cheat.
We actually thought about that a little bit. We're like, maybe it will become like an opportunity for like who's the best cheater. Like it becomes a fun.
Yeah, it'll be fun hacker talk.
Yeah, exactly. Yeah. Cool. Any other questions? One more.
I think just as like a final thought, I think we're all like ripping this apart. It's super interesting, super complex, and we just like want to figure it out. But seriously, like, great job.
Yeah, great
Cool.
job.
That might be the record for most comments and questions after a talk. And my head hurts. That's
Oh,
good.
sorry. Have another beer.
It's yeah, damn, that was great. Awesome. Well, we still got beer. There's a cardboard of the pizza boxes. There might be cheese stuck to them or something if you want some. If you had suggested something for what's going on in JS Land, please come up to me after this so you can get into the lottery for Friend Masters 3-month subscription. We got 2 available because we already gave 1 to the first guy.
And you also have to come up and claim that, and then we'll get your information. So sweet. And then, so yeah, those guys come up. Everybody else, thank you for coming, and think about stuff that you're interested in for next month, and we'll get you guys some subscriptions. If you keep coming, it's an odds game, right? You're going to get it eventually. So,
Also, come see Garrett, or myself if you have an idea for a talk. We're booked up next month, I think, right?
maybe. But we're always looking for speakers. That like never happens that we're booked out a month in advance. So just like come into the stuff.
So that one time I was booked up for 3 months thinking I was all cool, and then I dropped the ball. No worries. Cool. Thank you.
Thanks, guys.